Resistor in series and parallel. That's what we're going to be talking about. So when you say a resistor is in series, is when these are two resistors. Two resistors are said to be in series when one end is connected to the other end in this manner, so that they look like this, so that they are connected like this. So this is a series connection. So these two resistors are in series connection. Now, when you say a resistor is in parallel, when you have it connected such that it is connected like this, look at it now. You see now, this resistor is in parallel. Now, the value of the resistances, the resultant resistance that you will get from this parallel connection will be different from what you will get from the series connection. So let's do a quick calculation about that. So this is going to be simple. So let's use our symbol. First, let's talk about resistor in series. Resistor in series. Resistor in series. So I'm going to use our symbol, so just quickly draw that. So I will use the American, let me use the British standard. Sorry about that. And the second resistor. Alright, these are two resistors in series. You can have as much as possible. You can have 3, you can have 10 in series. So let's give them a number. Let's call this one R1 and let's call this one R2. How do you know the value of the total resistance of this resistor? It's simple. The total resistance R, let's just call it RT, is equal to the sum of R1 and R2. That's R1 plus R2. So for example, if R1 is equal to if your R1 is equal to 2200 and your R2 is equal to 4700, are you following me? The R2 is equal to 4700. What will be the total resistance? Right, you can already guess. The total resistance will be equal to 2200 plus 4700, and that will be equal to I'm looking at 4 plus 2, 6,900 ohms. That will be total resistance. It's as simple as that. So if you have resistor in series like that. Now let's talk about resistor in parallel. If you have two resistors in parallel, what will be their resultant resistance? Don't forget how parallel looks like. The circuit diagram will look like something like this. Yeah, something like this. Let's call the first one also, let's call this one R1 and let's call this one R2. Let's call this one R2. Now the resultant resistance, let's call it R total. in this case is different. Is first the multiplication of R1 multiplied by R2 all over R1 plus R2. Alright, you're already thinking this is getting complex, right? It's not. Alright, so let's quickly solve this. So let's see the same values. If R1 were to be 2200 and R2 were to be 4700, it's going to be 2200, 2200, then that looks like 6. 2200 multiplied by 4700 all over 2200 plus 4700. So once you do your, let's do the multiplication and the sum. 2200 plus 4700. That will give us 2200 times 4700. That's 4700. That's a lot. 10,340. 10,340,000. All over 2200 plus 4700 all over 6900. So what is going to be, let's finish this up. Let me clean up this side. Let me just, alright, good. We can write it. So once we do the division, you will get 10,340,000 divided by 6,900. The resultant resistance is 1,498.5 ohms. Yeah, so you can approximate it to 1,500. 1,500 ohms. What did you notice? You notice that the resultant resistance is lesser than the smallest resistance in the circuit. That's how parallel circuits work. So if you have two resistors, one is 10,000 ohms, the other is 1,000 ohms, and you connect the two together in parallel, the resultant resistance will be lesser than 1,000 ohms, like that. So sometimes why do you need to connect resistors in series or parallel? Maybe you need a unique combination and you can't find that exact value in the market, or maybe they don't even produce that exact value. So you may have to combine resistors in series and parallel to get that exact value. But in most cases, designs are not that critical, except you are building for a medical product. So you can always play around the values that are available in the market. Did you get it? Alright, I hope you really understood that. But in case you don't understand, you can just use the comment section. You can join, you can drop it on the community, or the Telegram community. Alright, so that is resistors in series and in parallel. There's one